I'm Barry Lerner with today's HAZCOM report number 6, which we call Physical Hazards 1, Explosives and Flammables. There are two main classifications of hazards associated with chemicals, physical hazards and health hazards. These are the two general ways chemicals can harm you. Let's start by reviewing what these hazards are. Physical hazards are things that can hurt you by catching fire, exploding, or reacting dangerously in other ways. Health hazards, the other basic category, affect your health adversely either immediately or over a longer period of time. Today, we're going to talk about the categories of physical hazards called flammables, combustibles, gases, and explosives. In a later program, we'll cover the others. These chemicals can hurt you in a number of ways if they're not handled safely. They can catch fire and burn you. When some chemicals burn, they give off dangerous vapor that can irritate your eyes, skin, or lungs. A physical hazard like this can also be a health hazard if you're not protected. And of course, an explosion can burn you, knock you down with its shock wave, or injure you with flying debris. I'm sure you've been around flammables and explosives at one time or another. They include many common substances you may encounter at work or at home. Here's a filmed report illustrating the different categories we've discussed. Let's watch.
Flammables give off enough vapor at fairly low temperatures, below 100 degrees Fahrenheit, to catch fire if ignited. Ordinary gasoline is a flammable liquid. Combustible liquids, on the other hand, do not produce ignitable vapors until they're heated to 100 degrees Fahrenheit or more. Kerosene and fuel oil are examples of combustible liquids. There are also solid combustibles, such as paper and wood. Some compressed gases are highly flammable, such as acetylene, which must be stored in special cylinders and kept away from excess heat. Other compressed gases, such as nitrogen, are non-flammable, but will displace oxygen in the air and can suffocate you. An explosive can be a gas, liquid, or solid. Explosives can be set off by heat, pressure, shock, or a combination of factors. Dynamite, for instance, must be detonated by a fuse or blasting cap to cause it to explode. Mercury fulminate, an initiating agent, can explode instantly if exposed to a mild shock, such as the tap of a pencil. It's an example of a primary or initiating explosive.
Well, you can see that these kinds of chemicals can injure you in several ways. So how do you find out how to protect yourself? As with any hazardous chemical, labels and material safety data sheets, the MSDS, are your first line of defense, but you have to use them. This MSDS for acetone, for instance, has information about the chemical's fire and explosion hazards. It shows the flash point and flammable limits. But what do these terms mean to you? For that story, let's go to our resident expert, Professor Sharp. Professor, how about explaining some of the terms about flammability we're likely to find on an MSDS?
Glad to, Barry. Now, I'm going to use my HAZCOM glossary as a handy reference for some of these terms, just as you can. Now, first of all, the flash point of a chemical is the temperature at which a liquid will give off enough vapor to ignite. Now, various tests are used to determine flash points, and the type of test used will be shown on the MSDS. Now, the MSDS will also show you the flammable limits of a chemical, expressed as a percentage of concentration of fuel vapors in the air. The lower flammable limit is the lowest concentration it will burn if ignited. On the other hand, the UFL, or upper flammable limit, is the highest percentage the fuel vapor in the air will burn if ignited. Now, any higher concentration is too rich to catch fire. Now here's that MSDS on acetone again. You'll notice that the flash point is minus 4 degrees Fahrenheit. So acetone is a serious fire hazard because it continues to vaporize even at very low temperatures. And here is shown the lower flammable limit of 2.6% and the upper limit of 13%. Now this means that any concentration of acetone vapor in the air between 2.6 and 13% will burn if it's ignited. You'll also find information on firefighting procedures here on the MSDS. Now let's go back to the HAZCOM news desk and Barry Lerner.
Thanks, Professor. You know, alertness is very important when you're working around any hazardous chemical, but it's especially important when it comes to detecting fire hazards. If you smell an unusual odor around your workplace, it could be a flammable vapor leaking. Check it out. If you can see a vapor cloud, report it immediately and clear the area until you find out what it is. Anything spilled on the floor could be flammable, so don't take chances. Remember that vapors can travel a long way to find a source of ignition. Obviously, anytime you see smoke, report it immediately and prepare to take emergency measures. To illustrate how flammable materials are controlled in an actual work environment, we have this taped report from a plant where the safety engineer is orienting new employees on fire safety. Let's watch.
Okay, here we're storing ethyl alcohol. Now, all flammable materials at the plant, they're identified with a label like this one. In addition to the warning flammable sign, we have a labeling system designed by the National Fire Protection Association, NFPA for short. The top portion of the label is colored red. Now, it classifies the flammables with numbers from 1 to 4, with 4 being the most flammable. What are those other numbers for? Well, the number in the blue area of the label that indicates health hazards. And over here, the number in the yellow triangle, that stands for the reactivity of the chemical. And the bottom block is for any special information. Sounds like this ethyl alcohol is dangerous stuff. Can it leak out? This is a specially sealed container with a layer of inert gas at the top, which prevents a flammable mixture from developing. Are those sprinklers up there? Right you are. And we also have CO2 fire extinguishers available, which are the type of extinguishers called for in the MSDS. Let's take a look at it here. Now here in the fire and explosion section of the MSDS, you see that the flash point temperature is only 53.6 degrees Fahrenheit. Next to that, it shows that the lower flammable limit is a 3.3% concentration in the air. So this chemical is very flammable, and that's why it's so important to keep it contained. Now, let me show you a couple of devices that we use around the plant to detect fire hazards. This is a portable gas detector we can use in hazardous areas. The gauge tells us the concentration of a gas or vapor in the air, so we know if it reaches a dangerous level. Now here we have an industrial version of a smoke alarm which we have located around the plant. It looks about the same as a smoke alarm that you may have, and you should have, in your home. Well, it looks like we're pretty well covered. But if a flammable substance does leak out, it takes something to set it off, doesn't it? Sure, we call that an ignition source, and you should know what the various ignition sources are. Some of the more common things around the plant that can ignite a flammable substance are welding torches, electric heaters, any kind of running electric motor, static electricity, or even a cigarette. I guess it's up to us to be extra careful whenever we're working around hazardous areas to prevent fires. You've got it. Personal awareness is your best protection.
Worker awareness has prevented more fire accidents than we can imagine. To illustrate that point, we're going to interview some employees at the Standard Chemical Company whose alertness averted a potential disaster. I'm talking with Jack Cates, a foreman at Standard Chemical, and Bill Jones, who was on fire watch during the crisis. Welcome to the HAZCOM report, gentlemen. Jack, tell us what happened.
Well, it all started when one of our workers was unloading a tank truck full of X-29 solvent into one of our storage tanks. The coupling on the hose apparently came loose. We're not sure why yet, and the solvent spilled all over. Now, the worker cleaned up the spill at the pump site, but a fair amount of the stuff had already run into a chemical sewer at the loading zone. Unfortunately, the worker didn't take the next step and report the spill to his supervisor or the safety engineer.
That's where you came in, right, Bill? What happened next?
Yeah, well, I was working as a fire watch with a welder. He was doing some repairs in another area of the plant grounds. Now, where we were was downstream from where the spill took place. And there's a chemical sewer opening there, too, see? Anyway, I began to smell something funny in the air, kind of a strong fuel odor, you know? Pretty quick, I figured out it was coming out of that sewer opening near where the welder was. Now, I didn't know what kind of fumes were coming out of that sewer, but I wasn't about to take any chances. So I ran over to the welder and told him to knock it off.
Let me guess, it was that spilled solvent, wasn't it?
It sure was. I got with Jack and he had some safety people come by and check it out.
Yeah. When they took a sample, they found a nearly combustible concentration of X-29 vapor coming out of that sewer. If Bill hadn't acted like he did, we could have had a major fire. And besides, when that solvent burns, it decomposes into cyanide gas, real poisonous stuff. Because of what Bill here did, we avoided a bad accident. It's good to see people like Bill take our safety training to heart.
Good work, Bill. And thank you both for sharing that story with us. We've talked about flammable and combustible chemicals that can burn you and create health hazards. But what about explosives? They pose the additional hazards of shock waves and flying debris. Let's go back to Professor Sharp for some important details.
Hello again. All explosions share the common properties of rapidly producing heat and gases that exert sudden pressure on the surrounding environment. That's what makes them so dangerous. And there are two basic types of explosives, so-called deflagrating explosives, which burn very rapidly but usually don't detonate, such as nitrocellulose, and detonating explosives, which can be either primary or secondary high explosives. Now, primary high explosives, such as mercury fulminate, can explode instantly if exposed to a small spark or a mild shock. Secondary high explosives, like TNT, are less sensitive and require strong mechanical shock or some other initiator to explode. Explosives can be solid, liquid, or gaseous, or combinations such as dynamite, which contains nitroglycerin, sodium nitrate, wood pulp, and a small amount of antacid. Now, generally, the more dense the explosive material is, the more violent and dangerous they are if not handled properly. Now back to HAZCOM Central.
Like flammables, explosives are only dangerous to life and limb when they get out of control. We have Harold Cummins from a specialty blasting company ready to be interviewed about how they control explosive substances. Thanks for agreeing to talk to us, Harold. What kind of explosives do you store at your facility?
We use several different types of explosives in our line of work. These include blasting caps, explosive water gels, and occasionally even dynamite. A major ingredient in all these explosives is ammonium nitrate. One way to explain the hazard of this chemical is to say that it has an explosive power that is 1.5 times greater than TNT.
That says a lot, all right. How do you keep such a potentially destructive material tamed?
The key to safe handling and storage of any explosive is to make sure it is stored in a tested and approved container, such as this special vessel. The tanks are also segregated from one another and from buildings, highways, and the like. We follow the guidelines published in the American Table of Distances for Storage of Explosives to tell us how far from inhabited buildings, public highways, and railways to locate our storage. Anywhere there are explosives stored, it's very important to maintain good housekeeping. To keep the area clear of oily rags, paper, or any flammables. And of course, all employees who work around explosives should be thoroughly trained in handling and emergency procedures.
Good practice in dealing with any hazardous chemical, Harold, and especially so with those chemicals that can cause so much havoc. Thank you for joining us on the HAZCOM Report. Knowing the hazard and following procedures will go a long way toward keeping you safe around explosives. Here are some basic tips about dealing with either explosives or flammables. Keep flammables and explosives isolated. Store and transport them in the proper containers. Keep your work area clean and well ventilated so there's less chance of a fire getting started. Keep any possible ignition source away from flammables and explosives. Make sure you have extinguishers and protective equipment handy, and know how to use them. And finally, know and follow the safe procedures indicated by labels, MSDS, and your own company policies. Now it's time to wrap up today's HAZCOM report on physical hazards. In this program, we've looked at some of the different types of physical hazards classified as flammables, explosives, and compressed gases. Professor Sharp explained terms of flammability and explosives, such as flash points, flammability limits, detonating, and deflagrating explosives. And we saw illustrations of how these chemicals can cause injury by burns, irritation of the eyes, skin, and lungs, and by explosive shock. We showed you ways to detect flammable and explosive conditions, such as smelling vapors, noticing a vapor cloud, watching out for spills that could catch fire, and reporting any smoke you see. We discussed firefighting equipment and procedures, and we reviewed some detection equipment that's used to prevent fires and explosions. And we learned some basic tips about keeping safe when dealing with flammables and explosives. In future programs, we'll talk about how to stay safe around other types of physical and health hazards. In the meantime, I'm Barry Lerner, and this has been the 6th in our series of HAZCOM reports.